Hi everybody, for our next installment of Properties of Minerals series, we're going to talk about something called cleavage. Cleavage is the ability for a mineral to break or split along flat, even surfaces. Now the opposite of cleavage is fracture. So fracture is something that does not break along flat or even surfaces. And sometimes that's an easy thing to determine, and sometimes it's pretty tough. Give you an example of one that's pretty easy is going to be these. This is mica. The clear one is muscovite mica, and the black one is biotite mica. And this actually shows perfect cleavage. And you're looking at it probably going, how's this even a mineral? It's flexible. Well, believe it or not, it is. And this is cleavage along one surface. So think of this like sheets of paper all put together, and you can peel one piece of paper off. That's what this is like. This is a perfect example of what cleavage is. Another good example of cleavage is this. This is optical calcite, also known as Iceland spar. And you can see that it has this nice rhombohedral shape. And when we talk about crystal systems, we'll talk about that a little bit. But you've got a nice flat surface here, a nice flat surface here that is not quite at an angle, or not quite straight. So it's not quite a 90 degree right here. And you can see even this direction, it's not quite a 90 degree. So this has nice cleavage on three sides, because the other side is going to be parallel, so it'll be the same. But this has nice cleavage on three sides, and they're parallel to each other. All right. Now, here's another example. This is also calcite. We've got a nice flat surface here, a nice flat surface here, and this surface is, you can see it's kind of stair-stepped where the smaller pieces have broken off. So this cleavage, okay, matches up with this cleavage. And it also matches up with this cleavage. You can see that the angles are similar. This is also another hunk of calcite. Now remember, what I said about cleavage is that it would break on flat surfaces. So if I were to break this, I would break pieces off with a similar shape to its crystalline structure, which was this guy. So any piece that breaks off, no matter how small, is going to have roughly this same sort of shape. That is cleavage. I'll show you one more example of cleavage. Actually, I lied. I'll show you two more examples. This is halite, and halite has a cubic crystalline structure. Notice how these surfaces are parallel, and this is a 90 degree, and this is a 90 degree to it. And if you look real closely in here, try and get that, there's a chip out of this, and that chip is also in a cubic shape. So this is an example of cubic and cleavage. And this is galena. This is also an example. We can see here, real nice cubic shape on these. All right, here is the one place where cleavage kind of gets a little tricky. We've got this really nice piece of quartz. And you're going to look at this quartz and go, well, of course it has cleavage. These sides are smooth, and they're at angles to each other, and they all have this same shape. And the problem with this is that this is the way the crystal grows, but it doesn't break this way. If you broke this, if you hit it with a hammer, you would just get this rough surface. You'd get this. This does not have cleavage. This shows fracture. Okay, fracture is where it does not break along smooth surfaces. This has fracture. If you hit this with a hammer and broke it, it would just break into random shaped pieces. All right? Cleavage is a pretty important way of being able to identify your mineral, but there's a couple ones that are a little tricky, like that quartz. that sort of makes it tough. So it's a little bit of knowledge and it's a little bit of experience. All right? Awesome, guys. See you for our next video.